Welcome back for the last page of terms. I think I can get all three of these on one page. So we are looking in the theory section. And we have already talked about a few of these, variable and constant. We looked at inverse, term, and coefficient. And so now we are up to the last three of these terms. And I want to start with expression because that's sort of where we left off in the last problem. So let's define the algebra term expression. An expression is a math statement or math sentence, you could even say there. I like statement better. That does not have an equal sign. It cannot be solved. But it can be simplified. So let's think about an example. Let's say 3x plus 2 plus 5x plus y plus 6. So this is a rather long expression. Notice that it does not have an equal sign. That's what makes it an expression. It cannot be solved because it does not have an equal sign. It can, however, be simplified, and I want to show you how to do that. The first question, though, I want you to ask yourself before we start is how many terms are in this expression? So let's count them, and as we count them, I'm going to color code. So here is one term. 3 times x, so 3 is a coefficient, plus 2, that's a second term. That's a constant, but it's a term, plus 5x, that has a coefficient and the x variable. Whoops, that doesn't look very good. Then plus y, that's a variable term. And then finally, another constant term, positive 6. So to answer my question, how many terms, we just need to count those colored boxes. And there are 1, 2, 3, 4, 5. 5 separate terms in this expression. Okay, so let's watch what happens here. I'm going to do a process called combining like terms. And this is why I color-coded for you to help you see the like terms. So let's look at the 3x plus the 5x. Those are like terms because they both have x's. The coefficients don't matter. They're like terms because they're x's. So I can simplify this a little bit by saying 3 plus 5 is 8. So think of that as 3 x-rays plus 5 x-rays, total of 8 x-rays. Okay, then I have the plus y, and there's nothing else that's blue. That's the only blue term in my expression. So there's really nothing I can do there with that one. Just separate that term from the x's. You cannot mix x-rays and yo-yos. We have 8 x-rays and 1 yo-yo, and those two cannot be combined. And I'm just using x-rays and yo-yos out of the blue. There is no meaning to that. Just trying to get you to think of these as separate things. Okay, then I have the plus 2 and the plus 6. So that's a positive 2 plus a positive 6. That's a positive 8. And here's the simplified version. 8x plus y plus 8. So we would say that this is simplified. And I know that because, well, let's count the terms and see what we come up with. So before we had 2x terms, and now we only have one term. The coefficient's an 8, but we just have one term. And we still only have one y term because that's all we had to start with. So that one didn't change at all. And then the constants came down to just one term. We combined those. So in the simplified form, we only have 3 terms. And that's as far as we can go. There's nothing else that can be combined. So simplified down to 3 terms, but that is still a much shorter mathematical statement. Okay, let's look at an equation. And an equation is one of the most fundamental pieces of mathematics. If we could not write equations, we would not be able to do very much with math. An equation is a math statement with an equal sign. And as soon as I put in an equal sign, it can be solved. Okay, so let me show you an example of an equation. I've actually shown you some of these before. We just weren't calling them equations per se. But let's take the equation x plus 5 equals, there's the equal sign. That is what makes the equation, the equal sign. So what I am wanting to say is that 2 sides are equal, that this amount on the left and this amount on the right are exactly the same. That's what equation means. So let's use our example of the box because I haven't shown you how to do these yet. So x plus 5 is 10. So I have 5, there would be 6, 7, 8, 9, 10. So 5 plus 5 equals 10. This side equals 10, and this side, of course, is 10. So this is a balanced equation. It's true. And that's what we're doing with algebra. Our goal is to balance equations. And you'll see that over and over. We will be using, instead of that little box or that little rectangle in this problem, we will be using variables to represent those unknowns. Okay, there's one more thing that I need to show you, and I need another page. Fortunately, I have one. And that is an inequality. And let's break this down with some English and figure out what this word means, because that will help you understand the concept. Okay, the first thing I want you to notice is right here. In equal. All right. This means not, and equal means the same. So an inequality is a math statement that says two amounts are not equal. So let me give you some visual examples here. What if I told you that 2 plus 3 equals 6? What would you think? 2 plus 3 equals 6. Well, hopefully you realize that 2 plus 3 is 5, and that does not equal 6. So one way to say that is just with a line through your equals. That 5 does not equal 6. That is one way that we could say this. Another way would be to say that 5, let me do it correctly here, 2 plus 3 is less than 6. Okay, so because this is 5, the less than symbol is this way. So we could say that 2 plus 3 or 5 is less than 6. We could also say that 6 is greater than 2 plus 3, because remember 2 plus 3 is 5. So 6 is more than that. 6 is greater than 2 plus 3. There are other ways of saying these expressions, and I don't want to get into those right now. But just to give you an idea of what an inequality is, it's usually going to have one of those arrow symbols in there. It's not equal, so it's either greater or less than. But sometimes it can be other things, so I'm just going to leave that there. But I at least wanted to point out to you what the word inequality implies. So you have several terms now under your belt. There is a quiz in the next page or on the next page for these terms. You also have a set of flashcards that I provided to you. So I would practice these until you know them very well. You will see me use these in the future modules, so you really need to know what they mean. And I think all of them are important. I wouldn't say that one is more important than the other. Please don't assume that the order matters. They're all important. So please work on learning those so that you can understand your future professors and also word problems on exams. These are important terms to know. I will see you in the next module when we look at one-step equations, and we will begin using the things that we know to solve equations. Actually, I take that back. I'll see you in the next video where I show you the golden rules of equations, and then we will start solving them. So I'm going to stop this video. I'll see you in just a minute on the golden rules part.